Welcome to 7.4. Last time we ended with simplifying an expression or evaluating an expression. We turned it into an equation because that honestly made it easier. But today we're going to just straight up do equations and then some inequalities, and things are going to get a little interesting. So first things first, if they give us an equation here, this is just going to circle happily around, just like we ended the other day. Do that circle method to rewrite it. Now, you can plug that straight into your calculator. This one, if you thought about it, I bet you most of you might be able to do it in your head. Because if you remember where we can rewrite these as a square root of 9 and then cubed, well, heck, the square root of 9 is 3, and 3 cubed, 3 times 3 is 9, times 3 is 27. Or just plug this into your calculator, either way, but the answer is x equals 27. That's all you do. Okay, same here. If I want to just do that, 16 to the 5 halves equals x. Okay, if you want to just plug that into your calculator, or you can do, if you plug it into your calculator, you're just going to get 1024. If you want to do it by hand, that becomes the square root of 16 to the 5th power, which is just 4 to the 5th, which is 1024. I think we're going to maybe watch this in class. This is a really good video about why logarithms can't be negative. She explains it way better than I can. We'll watch it in class, or maybe I'll post the video too. But for now, take my word on it that a logarithm cannot be negative. So, first things first, what we need to recognize, when I do the circle method here, I've been writing that as 4 cubed equaling the x. Now, if you look at what it actually says I should be doing, that is log, when I have this base, notice it actually puts the x on the left and the b to the y on the right. That's not very important because we know that, it doesn't matter which side of the equation it's on. If it equals itself, it always equals itself. Except that this inequality sign is going to kind of mess this up a little bit. When I do my circle method, I end up in the opposite spot as that. So I'm going to need to switch my sign. Okay, at the end of the day, I really just need you to know, flip the sign and you're good to go. Now that, I can go ahead and simplify. 4 cubed is 64. And I'm going to rewrite that with the variable on the left because that's just how we like to see that. And I notice since this small side is pointing towards the 64, I better make sure that the small side is still facing the 64. Now, something I want to take a pause and notice is that it says x is bigger than 64. That means there's no possible way it's going to be negative. So this is my answer. 3b is going to do something a little different. 2 to the 4th, flip the sign, x. And 2 to the 4th is 16. Use your Powers Pocket Guide there. And I'm going to rewrite that. X is less than 16. Now hold up a second. X is less than 16. We just got done saying that x can't be negative. So if you get to this point where it says your variable is less than 16 or less than a number, that means technically, yeah, it can be negative, but for log rules, it can't be negative. So just adjust that by saying, no, it can't be negative. Just add that 0. 0 is the smallest it can go. And actually, it can't even equal 0. It just can't. It's got to stay bigger than 0. So in a situation like this, tag on that x is less than, and you should be good to go. Now, what happens if there is a log on both sides? So first of all, when I had, like this equation here, the bases are the same, so those canceled. 2 equals x plus 2. That was pretty easy to solve. Well, it's the same thing for logs. If you have a log on both sides and there's nothing else on each side, it's just that log, your logs can cancel. So now, again, only if they have the same base, though, and in this time they did. And for today, they should always be the same. We'll explore later what happens if they aren't. So x squared minus 15 equals 2x. Admittedly, this is one of the more difficult problems. I don't know if you're going to see too many with x squared. But just in case, this is probably one of the most difficult ones. So there you go. What I'm going to do is make it equal 0. I'm solving for x. Because I have that squared, I recognize that I might be stuck doing like a quadratic formula, or completing the square, or graphing, factoring. All of those are ways that you can solve. So what I'm going to do is I'm probably going to do factoring, because I can, with fair ease, see that this is going to be x minus 5 and x plus 3, because negative 5 times 3 is negative 15, but negative 5 plus 3 is that negative 2. Okay, now, if you remember, what was this, chapter 4? I can split this into two equations. Now, by all means, I think that those are both my answer. However, you need to plug these back into the original problem, because sometimes weird things might happen. For example, and I'm kind of running low on space here. Here we go. Nope, that didn't work. Log base 3. I'm going to plug in the 5 first. So that would be 25 minus 15, so 10. Now, we're not expecting you to do anything with the log base 3 at this time. 2 times 5 is 10. But you should be able to tell if they're the same. And since they are, 5 is definitely an answer. So I'm going to go ahead and box that, because I know it's an answer. Now let's try plugging in the... what is it? The negative 3. So let's see if, can I erase just those? Cool. Okay, so now if I plug in the negative 3, see how I'm just plugging those in there, kind of cheating a little bit. That's okay. Negative 3 squared is 9, and 9 minus 15 is negative 6, and 2 times negative 3 is negative 6. Okay, it looks like they do equal each other, so I'm going to go ahead and star that, yippee-ki-yay. However, again, what was that video that we watched? You can't, or that we will watch, that we've discussed up here though, you cannot have a negative logarithm. I come back here, what did I end up with? Negative logarithms. So that means x equals negative 3 is not an answer. There's only one answer to this one, and it's 5.